chapter. So now we'll start the 12th chapter, that is Introduction to Three-Dimensional Geometry. So, like how you learnt the basics of coordinate geometry in your 10th standard, here we'll be seeing the basics of three-dimensional geometry. We're not going to get into much technical aspects of it, just like what is distance formula in three-dimensional space and what is the section formula, all those things we are going to see. Okay. So listen. So I'll put it in very simple terms. So here we are saying introduction to three-dimensional geometry, right? So if I speak something about one dimension, if you are able to draw a particular shape in one dimension, what would be the name of that shape? So one dimension means it is associated only with one particular direction. So if I'm able to take set of points which are aligned along one direction, then the shape that you get by joining all these points is going to be a straight line. Yes, it's right. It's a straight line. So anything related to one dimension has to be a straight line. Second, then what about two dimension? What is the shape that you can draw through two dimension? So anything, see, for example, you are writing on a paper, right? The paper on which you are writing, if you take a single sheet, that paper is a two-dimensional plane. Okay. So anything related to two dimension is called as plane. Means you can define two variables associated with it with respect to the reference called as origin 0, 0. Okay. So here, if I take this as the initial point, if I take this as a 0 point, so with respect to 0, I can say whether a particular point is so I can talk about the distance of a particular point from this reference point O, where I can say x is the distance from it from origin to right or left. If it is to the right, I'll take positive. If it is to the left, I'll take it as negative. Similarly, in a plane, if I take the reference of two variables, that is x and y, then I can define the coordinate of any point. So the coordinate of any point, if I say about two dimension, it is always measured in a plane. Then what is the technical name given for three dimension? So if one dimension, I call it as a straight line, two dimension, I call it as a plane, then what do you call three dimension as? It's called as space. Okay. So that's what this chapter's introduction is all about. So in this chapter, we shall study the basic concepts of geometry in the three-dimensional space. Guys, am I clear? See, for example, we are there. We are in which room? We are in a three-dimensional space. Right? Are you guys able to understand or not?
Yes, sir.
Yes, sir.
Okay. So for one dimension, we will take a single axis. For two dimension, we will take two axes. For three dimension, we will take three axes. So x, y, and z is something which is towards us. Okay. So I will show you all these things. So that is how it is defined. See, x dash is x axis, y dash is y axis, z dash is which axis? It's the z axis. Okay. So before I proceed, you need to actually visualize. So what we need to do is, so do you guys remember the distance formula in two-dimensional plane? So what is the distance between 2 points x1, y1 and x2, y2?
Root over x2 minus x1 the whole square plus y2 minus y1 the whole square.
That's right. So if I put a question like, how did you get it? What are you going to say? Why is it only that formula? Why not x2 minus y2 the whole square plus x1 minus y1 the whole square? Why is it not like that? How did we actually know that this is the distance formula? So if I take, can someone tell me? So if I take one point as x1 by 1, other point as x2 by 2. From the point, if I drop a perpendicular, what is the distance from the origin to this point?
x1.
x1.
And this distance is
y.
y. Again, if I drop a perpendicular, this distance is
x2.
x2. And this distance is y2.
y2.
So if I join these two, if I drop a perpendicular, then this distance is x2 minus x1. And this distance is y2 minus y1.
y2 minus y1.
So what is that you're able to get? You're actually able to get a, you're able to find, I'm extremely sorry, 1 minute. You're able to find a right angle triangle here.
Yes, sir.
Yes,
So
sir.
to this right angle triangle, the distance between 2 points is nothing but the hypotenuse of it. That is why you're actually getting it as root of x2 minus x1 the whole square plus y2 minus y1 the whole square. Irrespective of which quadrant the point is. Right. So here you are able to visualize it because it's on a paper. You are able to clearly see. If I drop a perpendicular, yes, all these things are moving. Whereas in 3 dimension, we have to visualize it. Okay. I'll tell you how to visualize. But before that, listen. In 2 dimension, we have a concept called as quadrants. And you know how to define the location of a point in space, in plane. So why are we calling it as quadrant? Quadra refers to 4. Means if I take a plane, then if I draw a coordinate axis, a system of coordinate axis for it, that coordinate axis can actually divide the plane into 4 parts, 4 equal parts, and each part is called as a quadrant. So if the coordinate axis is in such a way that if the partition is on the right of y-axis and above x-axis, that particular quadrant is called as the first quadrant. Is a partition in such a way that it is above above x-axis and on the left of y-axis. We call it as second quadrant. In a similar way, you can extend the concept to third and fourth, right? I hope you're able to understand this, guys. So when I look at a point, if suppose I give you a point like this, 1, 2, you can directly tell me the point belongs to which quadrant.
First quadrant.
Right?
First
So it
quadrant.
belongs. So you're able to find it. How are you able to do that? Because you're able to visualize how that is going to be, right? Because we know what is the concept of quadrant. Whereas when so 2 parts are able to divide the 2-dimensional plane into 4 parts. Now here we don't have 2 dimensions, we have 3 dimensions, right? So what are the 3 dimensions that we have? We have x, y, and z. So we exactly need to visualize how this z-axis is with respect to. So you need to start visualizing how a point is going to be. Okay, that is the challenging part. Now I'm going to explain it. I'll switch on my video. Guys, carefully concentrate. Okay, just a minute. So I hope you're able to see it. See, this is the. If I take this pencil as x-axis, this pencil I'm keeping it as y-axis. If I keep it like this, it is easy for us to visualize. With respect to me, you can also do this activity and see. You can actually take 3 pens and keep it in hand, or three straight objects and keep it in your hand. Just keep it ready. So if I keep the pencils in this way, then with respect to me, when I see from this side, first, second, third, and fourth. If a point is taken here, yes, I know the location of it. Whereas, to this kind of a system, if I add one more axis, you're able to see, I've added one more axis. Guys, you're able to visualize this? No, sir. So, I'm taking it in this way that when I see from this side, see from my side, you can also do it as I told you. When I see from my side, this is the origin. Any point, so any direction on the right is taken as positive x-axis. left side is taken as negative x-axis. So this axis I am taking it as x dash. Similarly, this is y-axis. So anything above the origin, that is above x-axis, I am considering it as positive y. Anything below is considered to be negative y. Okay. So 1, 2, 3, 4. Now to this 1, 2, 3, 4, what I am trying to do is I am trying to bring in extra partition. That is, I am taking a pen and the cap towards me, the pen's cap towards me is taken as positive z-axis. Okay, I'm actually not able to hold it. So it is like this. So x-axis, y-axis. The pen's cap towards me is positive z-axis, away from me is negative z-axis. Are you guys able to visualize this point? So what is going to happen is, here we don't have quadrants concept, because what has happened, if I take a cube, right? If I take a cube, wait, let me check. See, for example, I take this mobile phone, okay? So through this mobile phone, what I'm doing is, I'm taking a pen and inserting in such a way that it is like this. Now this mobile phone, due to this axis, is divided into how many parts?
One pencil, sir.
Like this.
Divided into two parts, sir.
It's divided into, so due x-axis is dividing into two parts. I take a pen, I pierce it like this. Now how many parts?
4 parts.
4 parts.
Now if I take a pen and keep it like this, along with the z-axis, then how many parts will you be? So imagine the cube being there, okay? Imagine the cube is there. Okay, there's a cube. If I keep it like this, how many parts are you able to, how many parts is it broken into? This is cube's first part. This is cube's second part. Cube's third part, cube's fourth part. Fifth, sixth, seventh, eighth. It is actually divided into how many parts now?
8
Could you show
parts.
the 5th, 6th, 7th part again, sir?
See, you also do this activity. You people take two pencils, keep it like this. Okay. Second pencil, hold it with your central finger. Okay. Now, if I keep a paper here, okay, that paper is divided into 4 quadrants, 4 parts. Are you able to understand that?
Yes, sir.
Now I take a cube. Cube is a 3-dimensional shape. To that cube, I am keeping something like this. I am holding the pen in this way. Look at the way I am holding it. When I hold it like this, see, x-axis and y-axis together is giving me a rectangle. Okay, let me explain it like this. See, x-axis and y-axis put together. Can I draw a rectangle here?
Yes, sir.
Similarly, y-axis and z-axis put together. Can I draw a rectangle here? Can I
Yes,
draw?
sir.
Right. So one rectangle here, one rectangle here. If I take another parallel rectangle and keep it here, and another parallel rectangle and keep it here, what shape will you be able to see?
A cube, sir.
It's a cube, right? So if I have a very big cube, can I say this cube that you're seeing here is a small part of it?
Yes, sir.
Right? In a similar way, I have a sheet here. You're able to see this and this put together. I can form a rectangle.
Yes, sir.
Say for example, I got this paper. I'm able to keep a rectangle like this. Similarly, I can keep a rectangle here. So I can keep a rectangle here, I can keep a rectangle here. This will form another cube.
Yes, sir.
Like this, if you have a 3-dimensional shape, that is a cube in your hand, that cube can be broken into how many parts? Due to these 3 coordinate axes, it is broken into 8 parts because one cube here, the other cube here. So try to understand. So let me name it like this. X-axis, positive x-axis, y-axis, z-axis. So I will say there is a cube which is constrained to x-axis and z-axis here. That is positive x-axis, positive y-axis, positive z-axis, there is a cube. Similarly, negative x-axis, positive y-axis, positive z-axis, there is another cube. Similarly, what will be the other cube that you can find? X-axis,
Positive x and
Negative y
negative
and
y.
negative z.
negative y, and positive z. I can think of a cube.
Okay, so now I understood completely.
First z. So now you are completely able to visualize it, right?
Yes, sir. Understood,
Yes.
sir. Understood.
Yeah. So what I'm trying to say, So what I'm trying to say is, if you take a sheet, if I define only one axis, that one axis will be able to divide the sheet into two equal parts. If I define two axes, it will be able to divide the sheet into four equal parts. That's why we call it as quadrants. Quadra means two. Four. If I take 3 dimension, I will get 8 parts. Those 8 parts put together is called as octant. Am I clear? It's called as octant because octa refers to 8. Clear, guys? So now next thing that you're supposed to visualize it.
Yes, sir.
Visualize. So remember like this. So I'll do one thing. I'll show you in the paper, then I'll come back here. See, listen. Now you're able to visualize it. See, like what I tried to show. So I have a cube. A cube is actually broken into 8 parts. Right? Those 8 parts are technically called as octants. So, for example, I will try to connect the dots. If I give you a point -2, 1, you will say which quadrant it is. See, what is so tough about it? -2, 1, which quadrant is it?
Second quadrant.
Third
Second quadrant.
Second quadrant.
How did you find it as second quadrant?
Because
So what are the
x
meaning?
is negative.
Yeah. So you found. So these are the combinations, right? When I take x and y, first, second, third, fourth. Okay. So in first quadrant, x and y both are positive. Second quadrant, x is negative, y is positive. Third quadrant, both are negative, positive, negative, right? So depending on the sign of the abscissa and the ordinate, you are able to decide the quadrant. So you are able to say the point belongs to this quadrant. But here what is going to happen is the point is not going to belong to a plane. It is going to belong to a space. Right? So how are the octants? So what should be the sign of x, y, and z? And one more important point. So if I take this point as, let's say 2, 1, then the meaning of this is from the origin, this point 2, 1 is at a distance of 2 units along x-axis and 1 unit along y-axis. Can I say it like that? So from the origin means if I am drawing a line parallel to y-axis at a distance of 2 units, and if I'm drawing a line parallel to x-axis at a distance of 1 unit, they both meet at a point called as 2, 1. So that is the other meaning of it. So you're able to visualize. So similarly, -2, 1 means what? It is the point is still at a distance of 2 units, but instead of being on the positive x-axis, it is at a distance of 2 units along the negative x direction. Correct? And 1 means it is at a distance of 1 unit along positive y direction. So that is how the quadrants came into picture. In a similar way, there is a sign convention that is followed for octants also. Depending on the sign that we use, octants are classified like this. So what we will do is, first 4 octants will have the z-axis to be positive. The last 4 octants will have the z-axis to be negative. Okay, that is how you remember. Guys, am I clear to this point? So for the first 4 octants, fix z to be positive. For the next 4 octants, fix z to be negative. Now, Start writing x and y like how you write for quadrants. Positive, positive, negative, positive, negative, negative, positive, negative. Again, repeat the cycle. Positive, positive, negative, positive, negative, negative, positive, negative. That will give you the octant to which the point belongs to. Am I clear?
Yes, sir.
So what the moral of the story is, you have a cube. A cube by the 3 coordinate axis can be broken into 8 equal small cubes, right? In that particular small cube that is broken, if the coordinate of x, y, and z all are positive, then it belongs to first quadrant. If the coordinate of x is negative, y is positive, and z is positive, it belongs to second quadrant like this. Sorry, second octant. Okay. Now, you see this I took from the textbook only. You can have the textbook beside you. Now I'll ask you certain questions. You guys tell me. I'm again switching on my video. I cannot show this simultaneously. You can have your textbook open. Just have a check. X-axis, Y-axis, Z-axis. Okay. So when I'm seeing from this side, this is positive X-axis, positive Y-axis. Anything towards me is positive Z-axis by default. Okay. If I take a point here, I'm repeating it. See, X-axis, Y-axis, Z-axis, all positive. I'm taking a point here. This point belongs to which octant?
First quadrant.
Sorry?
First quadrant, sir.
First octet.
First octant. Okay. So if I, for example, if I take this point as 1, 2, 3, then what is the meaning of it? So if the coordinate of this point is, let's say 1, 2, 3, then the meaning of it is this point is at a distance of 1 unit from the origin along the positive x-axis, 2 units from the origin along positive y-axis, and 3 units from the origin along positive z-axis. You're able to understand? So the point has actually traveled like this. 1 unit like this, 2 units like this, 3 units like this, it has stopped here. That is why the coordinate of that point is 1, 2, 3. Similarly, if it belongs to this point, if I take it here, actually it is confusing, right? It is on the negative z-axis side here.
So, sir, is it in negative y-axis also, sir, or is it in
Negative y-axis, negative y-axis, negative z-axis, and negative x-axis.
seventh octet, sir?
So that is how the questions will be in the first exercise. Okay. Next important point I would like to mention is the plane that you are able to draw through the x and the y axis alone. So in a 3-dimensional space, the plane that you are able to draw through x and y axis is called as xy plane. The plane that you are able to draw through yz axis is called as yz plane. If you are able to draw through xz, it is called as xz plane. So in xy plane, z is 0. In yz plane, what will be 0?
X will be
X will be 0. So whichever is missing in that plane, that point will be 0. So this is how the questions will be in the first exercise. Let's try to answer them. If there is any doubt, ask. I hope you are able to visualize it, right? So look at this. In figure 12.3, if P is, so this point is 2, 4, 5, find the coordinates of F. So the point, so listen, point P belongs to dash octant. Look at the coordinates. All the three are positive.
First octet. Octants.
It
First
belongs to
octet.
first octant. Point F belongs to, see, point F does not belong to octant. It belongs to XZ plane. So plane should be written like this. X hyphen Z plane. So if X hyphen Z plane means what is 0?
Y is 0, sir.
Which implies Y is equal to 0. Since F and P are parallel to each other, point F will be what?
Equal to point P.
2 comma
2 comma 5, sir.
0 comma 5.
0 comma.
You're able to understand?
Yes, sir.
That is how we write. Similarly, I want to extend this question. I want you guys to tell me what are the coordinates of point D. Point D is also parallel to P. But point D belongs to which plane? You're able to see this?
XY planes.
Point D belongs to XY plane. Z is equal to 0, which implies coordinates of D are
2 comma 4.
2 comma 4. Don't forget 0. 2 comma 4 comma 0. Am I clear, guys? Similarly, point E. Point E belongs to which plane?
YZ plane.
Yes, it belongs to YZ plane. So coordinates will be,
0 comma 4 comma 5.
that's it. So coordinates of point A. Point A does not belong to a plane. It belongs to what? Point A is where?
Belongs to coordinate X
It
axis.
belongs to the axis. So A is on x-axis. X-axis means what? Y comma Z both are 0. So what will be the coordinate of that point?
2, sir.
See, 2 is a distance. Man. Coordinate
comma
is always 2 comma 0 comma 0. Guys, is there anyone having a doubt on this? This is the whole basic. I've just extended the question and explained it. What about point C? C belongs to which axis?
Z axis.
So what is the answer?
0 comma 0 comma 5.
That's it. Okay. So don't worry, you're not expected to draw this every time. Just need to understand. So if you see, for example, the reverse analysis, if suppose I give you a point 0 comma 0 comma 5, you need to understand that that point lies on y-axis. If suppose I give you a point 2 comma 5 comma 0, then that point is, if I
XY
give you,
plane.
it is in the xy plane. If I give 2 comma 4 comma 5, it belongs to the three-dimensional space. Okay. So that is what the logic. So minus 3 comma 1 comma 2. So how to solve this? You need not look at the table always. I'll tell you. So first look at whether Z is positive or negative. So Z is positive. So positive means it should belong to any one of the first 4 quadrants. Now look for X and Y. X is negative, Y is positive. In quadrants, X negative, Y positive belongs to which quadrant?
Second.
So here it is second octet.
Yes, sir.
What about minus 3, 1 comma minus 2? Z is negative. Minus 3 comma 1 belongs. So Z is negative means it should be from 5 to 8. So minus 3 comma 1. So minus 3 comma 1 is second quadrant. So between 5 to 8, 5 is first. 6 is second. So it belongs to sixth quadrant. You're able to understand, break it into 4 cycles so that you need not memorize that table. Sorry. No. -3, -2, -2. So -2, z is negative. So it should belong.
Sir.
Sorry?
7th octant, sir.
That's right.
Seventh octant.
So did you guys understand the logic of how to find it very fast?
Yes.
So first eliminate z, then look for the quadrant number. Okay, that will be the octant. Sorry, did I say quadrant? It is 7th octant. If I told quadrant, I'm sorry. It is octant, 7th octant. So next one. There is a point that lies on x-axis. What are the y and the z coordinate? Directly tell me. I just now told you. Any point lying on x-axis, y comma z coordinate will be
0.
0. So any point lies on y-axis, x and y coordinate will be, sorry,
X and Z.
coordinate, z will be 0. If suppose the question is like this, a point was on the x-axis, what are its x coordinate, y coordinate, and z coordinate? Okay,
X.
then you can say x is non-negative, non-zero, y and z are 0, provided that point is not the origin. Had it been origin, yes, it cannot be origin, right? Because it is lying on x-axis. Next, a point is in the xz plane. What can you say about its y coordinate? This also I told you. So x, y, z.
0.
So y coordinate is 0. Whichever is missing, that coordinate will be 0. For example, x-axis, y. So throughout the chapter, what you need to do is x, y, and z should be there. If they say only x-axis, then y and z are 0. If they say xy plane, then z is 0. Like this. Whichever is missing, that will be 0. Name the octants to which the following points lie. 1, 2, 3.
First octant.
So first, here the octant number. 4, -2, 3. Z is
Fourth,
positive.
fourth octant.
That's right. Fourth. 4, -2, -5. Z is negative, so it should belong to 5 to 8.
No. Eighth.
Correct only. 8.
Eighth octant.
Because x is positive, y is negative. So x is positive, y is negative, means 4, no?
Yes, sir.
So that's how you get. 4, 2, -5.
Fifth octant.
That's it. So -4, 2, -5.
Sixth octant.
That's right. -4, 2, 5.
3rd octant, sir.
Third octant.
Second.
Third, second.
Second.
Yes, second. -3, -1, 6.
3rd octant, sir.
Third
Third
octant.
octant.
So 2, -4, 7. -7, x, z is negative. So x is positive, y is negative.
Eighth octant.
8th octant.
Eighth octant.
That's it. Okay. So fill in the blanks. The x-axis and y-axis taken together determine a plane known as, you guys tell me. What is the name of that plane?
XY plane.
XY plane. So the coordinates of the point in the XY plane are of the form x,
X, y, 0.
So coordinate planes divide the space into
8th octant.
8 octants.
Yes. Is it easy? So that's all about the first exercise. Okay. So second exercise is all about distance and section formula. Okay. So you guys already know what is distance formula, you know what is section formula, right? So first, as of now, we'll do distance. Section I will teach you later. So find the distance between the points P and Q. So in 2 dimension, it is root of x2 minus x1 square plus y2 minus y1 the whole square plus it's that much only. In third dimension, what will happen? You will have z2 minus z1 square also getting added. So solution. So by the way, this is 12.2 exercise guys. So what is the formula for distance between 2 points? Root of x2 minus x1 minus 4 minus 1 the whole square plus 1 plus 3 the whole square plus 2 minus 4 the whole square. So square root of 5 square is 25, 4 square is 16, 2 square is 4. So it will be root of 20 plus 25, root 45 units. It's 9 root 5, 9 root 5 is nothing. So root of 9 into 5, that is 3 root 5 units. Guys, am I clear?
Yes, sir.
Yes, sir.
I didn't show you the derivation again because like whatever you did for the 2 dimension, you're going to do for 3 dimension. So that's it. It's the same derivation, same right angle triangle, and all the story is the same. Okay. Next. Show that the points are collinear. So when the points are collinear, what can you prove? PQ plus QR is equal to PR. So what you do is find the distance of all the three. You don't know which point is in middle, or you don't know how it is. Actually, assuming that they have given PQR, assuming that Q is a point in between. So what you do is find PQ, find QR, find PR. Sum of two distances should be equal to third distance. If that comes, they are collinear. Try to find out. So don't forget the square root, okay? Can you find out this? What is PQ?
Root 14, sir.
Root 14, huh? QR?
2 root 14, sir.
So PR is 3 root 14.
3
Did you
root
get
14.
it?
Yes, sir.
3 root 14 is 14 into 9, right? 14 into, okay. Would have done the prime factorization and found it out. Next, fifth one. Are the points A, B, C the vertices of right angle triangle? So they're asking whether are they the point vertices of right angle triangle. So what are we supposed to do? Find AB square, find BC square, find AC square. Find AB square, BC square, AC square. Sum of two should be equal to third one for it to be right angle triangle. What is AB square? Huh?
Square 686, sir.
686, sir.
Yes, sir.
BC square.
I think it's 4,571, sir.
Is it that big number?
So since 41 plus 20 the whole square.
Oh, 61 square and all are coming out. So how much is it? 4,000?
571, I think. So.
4,570. Similarly, you'll find, I think AC square will be one more big. Anyways, you understood the method, right?
Yes, sir.
Okay. See, had the same question come in 2-dimension, okay? We learned something, we learned straight lines. So if the same question I asked you like this, 3, 6, 10, 20, 25, minus 41. If I ask you to find if they belong to right angle triangle, I'm suggesting you should not use distance formula. What will you do? Right angle, 90 degrees means what comes to your mind? Product of slopes is minus 1. You remember this? So, guys, listen. You know this, right? So, product of slopes of two lines which are perpendicular to each other is minus 1. That is in which case? In 2D. Okay. Whereas in 3-dimension, as of now, the only formula that you have is using the Pythagoras theorem. Because for 3D, there is no concept of slope. I cannot use it here. I just mentioned it because you need to understand which formula to be used at what time to save your time. Am I clear?
Yes, sir.
Now listen. So 6th example I will do. Find the equation of set of points P such that PA square plus PB square is equal to 2K square, where A and B are the points 3, 4, 5 and minus 1, 3, minus 7 respectively. So let the point P be x, y, z. It is like the moving point, like how we derived circle equation, ellipse equation, like that. So PA square plus PB square is equal to 2K square. What is PA square? It is x minus 3 the whole square plus y minus 4 the whole square plus z minus 5 the whole square plus what is PB square? X plus 1 the whole square plus y minus 3 the whole square plus z plus 7 the whole square is equal to 2K square. So when I expand it, I get x square plus 9 minus 6x plus y square plus 16 minus 8y plus z square plus 25 minus 10z plus x square plus 1 plus 2x plus y square plus 9 minus 6y plus z square plus 49 plus 14y is equal to 2K square. So I collect all the x square terms. So 2 times x square plus y square plus z square minus 6x plus 2x minus 4x minus 8y minus 6y minus 14y minus 10z plus 14z plus 4z plus 9 plus 16, 25, 25 plus 25, 50, 50 plus 1, 51, 51 plus 9, 60, 60 plus 49, 109 is equal to 2K square. So this would be the required equation. Did you guys understand what I did? So I just applied distance formula and then collected all the x, y term, z terms separately and wrote an equation. Guys, shall I proceed?
Yes.
So, distance homework. Vertices of isosceles triangle, what are we supposed to do? A, B, C. If AB, find AB, find BC, find AC. If AB is equal to AC, or BA is equal to BC, or CA is equal to CB. If any of the two sides are equal, then they are the vertices of an isosceles triangle. Right angle triangle, again Pythagoras theorem. Vertices of parallelogram, what are we supposed to do? A, B, C, D. Find AB, find CD. Then what are we supposed to do? Find BC, find BC, find AD. If all the four are equal, like AB is equal to CD and AD is equal to BC, then we can say that it is the vertices of parallelogram. So find the equation of set of points which are equidistant from the point. Solution. Let the point be P, X, Y, Z. This is A, this is B. So what are they saying? Find the equation of set of points which are equidistant from the points A and B. So PA is equal to PB. Correct? So x minus 1 the whole square plus y minus 2 the whole square plus z minus 3 the whole square is equal to x minus 3 the whole square plus y minus 2 the whole square plus z plus 1 the whole square. So I've removed the square root because we can say PA square is equal to PB square also, squaring on both the sides. So get x square plus 1 minus 2x plus y square plus 4 minus 2y plus z square plus 9 minus 6z is equal to x square plus 9 minus 6x plus y square plus 4 minus 4y plus z square plus 1 plus 2z. X square gone, y square gone, z square. So minus 2x minus 2y minus 6z. So minus 2 into x plus y plus 3z, 1 plus 4 plus 9, 10 plus 14 is equal to 9 plus 4 plus 1 is 14 minus, again I take out 2 common, it will be 3x plus 2y minus z. So 14 and 14 are gone, 2 and 2 are gone. So you will get x plus y plus 3z is equal to 3x plus 2y minus z. So you will have 2x plus y minus 4z.
So I think there'll be no y, sir.
No,
If y
4.
minus 2 is there in both sides, so it'll get cancelled, no, sir.
Where?
It's given y minus 2 the whole square even in PA and y minus 2 the whole square in PB.
I could have actually cancelled here itself. I didn't check that. I think yes, you should not have y then. So y is not there means is this, check the answer is x is equal to 2z. I missed a 4 here. Rohan, what is the answer? X is equal to z.
Yes, sir, x equal to 2z.
Okay. Similarly, find the equation of set of points P such that the sum of whose distances from A and B is equal to 10. So PA plus PB is equal to 10. You people solve this. This is also homework. Okay. So let the point P be x comma y comma z. PA plus PB is equal to 10. There is a condition. So this will be homework. That's it. So we are done with 2 exercises. Tomorrow, first half itself, we can actually finish the 3rd exercise. It's a small chapter. Right? Is it easy, guys?
So,
Yes, sir.
So tomorrow we will complete it. Okay. Day after tomorrow, I will start limits and derivatives. That is very, very important. I don't want anybody to miss classes. It's important and slightly tough also. So you guys need to concentrate. Okay. So with this, we can wind up. Just wait for a minute.